It is incredibly difficult to teach 11-year-olds how to think critically about an algorithm they cannot even see. Most curriculums focus on showing students how to use these tools. The objective here is to teach them how to evaluate the technology, to understand the logic operating behind the screen. We have built a complete 4-part lesson plan to achieve this. To make abstract concepts concrete, the lesson is entirely unplugged. No computers are required. Before class starts, you only need 3 items: a whiteboard, student notebooks, and a stack of printed scenario cards. Removing the screens eliminates the illusion of magic. The students must confront the structural mechanics of the systems they interact with every day. The first step is an entry activity, where students identify hidden technology. Have your students take out their notebooks and draw a simple 3-column table. You will read aloud 5 descriptions of common features found in modern apps. For example, ask who uses an app that predicts the next word they want to type, or one that maps digital filters perfectly onto their moving face. If a student uses a feature like this, they stand up and log the specific app's name, like TikTok or Siri, directly into their table. Look around the room. Almost everyone will be standing. The realization is immediate. None of these apps announce that they are powered by artificial intelligence when they are opened. This diagram uses the metaphor of an umbrella to define artificial intelligence. Just as sports covers everything from swimming to soccer, AI covers a range of tasks, from facial recognition to driving cars. Deep under that umbrella is a specialized activity. In the sports world, that is basketball. In the computer world, it is a large language model. The broader AI acts as a general problem-solving brain. The large language model is a giant library inside that brain, focused entirely on predicting words and sentences. This leads to a specific layer of understanding, the how. Students need to learn that AI is the result of data combined with pattern recognition. This infographic outlines 2 additional concepts. The wait a minute is the critical thinking reflex to check if an output is wrong. The handshake is knowing when to collaborate with the machine and when to rely on human judgment. These 3 concepts form the mental framework students require before they attempt to evaluate any algorithmic output. Now we test that framework. Divide the class into small teams and hand each group 6 printed scenario cards. Their task is to sort each scenario into one of 3 categories: an AI strength, a human strength, or a task for the team. An AI strength would be spotting a specific star pattern hidden inside millions of telescope photos. The machine excels at rapid data processing. This chart contrasts that technical task with a human strength. Evaluating whether a new joke is funny requires empathy and real-world context, traits the algorithm lacks. Halfway through this exercise, pause the sorting to discuss the specific points where these systems fail. Ask the students what an image generator will draw if its training data only contains pictures of men. It will output exactly what it was fed. If the data is biased, the output is biased. Next, explain hallucinations. Compare the algorithm to an overconfident toddler. It wants to please you so much that if it does not know the answer, it will invent a believable lie. Highlighting these systemic flaws changes the dynamic in the classroom. The students move away from blind trust and adopt an attitude of active skepticism. To assess whether the students have internalized these concepts, skip standard multiple-choice tests. Use scenario-based role plays instead. In the first option, students act as consultants, reviewing hypothetical client problems and deciding whether to hire a human, an algorithm, or a team to solve them. The second option is the hallucination hunter. You provide a fact sheet about an animal, along with an AI-generated summary. The students must locate and circle the confident lie hidden in the text. The final option is a visual exercise. Ask students to sketch what they think happens inside their phone when it recommends a song. If a student draws a mechanical data sieve instead of a magical wizard, you have proof that they have successfully updated their mental model. We started with the app-identifying hook, built a conceptual framework, mapped strengths in the sorting challenge, and tested comprehension through practical scenarios. The result is a student who knows exactly how to categorize and evaluate the tools in front of them. All the specific prompts, templates, and academic frameworks you need are linked in the description below this video. You can implement this lesson plan tomorrow. Effective digital education begins with analog logic.